In this question, we have a relatively simple situation, but a large number of variables to work with. We have the girls, boys, and total in one group, and the same in the other group. Furthermore, we have all the ratios of those variables to work with. Since we're not keen on working with so many variables, we can get away with doing this purely by analysis by cases. So we will skip equation writing for now and go straight to the statements, evaluating them separately at first. Statement 1 looks insufficient because we want to know a ratio, and statement 1 is not giving ratio type information, but rather an absolute difference. We will try to generate multiple possible cases. Generating cases involves a degree of trial and error because we need to make sure those cases fit the information in the statement and the information in the question. One possible case is the following. Notice that the GB ratio in A is twice that of B. Also, the total in A is 30 more than B. Therefore, the main condition of the question and statement 1 have been met. This is a legal case. To come up with another case, we can adjust the GB ratios and still be sure to work in whole numbers, since girls and boys must come in integer numbers. That can lead us to a case such as the following. Here, the GB ratio is still twice in Group A what it is in Group B, and the total number of girls and boys is still 30 more in Group A what it is in Group B. But what we're being asked for, the ratio of the total number of girls and boys in Group A to Group B has changed. That ratio in our first case was 90 to 60, or 3 to 2, and now it's 120 to 90, or 4 to 3. So, with valid cases, we have obtained different possible answers to the question. That means we have insufficient information to answer definitively. Statement 1 is insufficient. Statement 2 gives information about the GB ratio in Group A. If the GB ratio in Group A is 6 to 5, then in Group B it must be 3 to 5 by the condition in the question. Coming up with cases for this statement is somewhat faster. We can do a case in which there are 6 girls, 5 boys in A, and 3 girls, 5 boys in B. The ratios in this case are the numbers. In another case, we can keep the ratios, but double the numbers in Group A only. Both cases fit all the information given to us, but in the latter of these two cases, the thing we're being asked, the ratio of one total to the other, has doubled. Therefore, we can't answer the question definitively, and with this information, statement 2 is still insufficient. Combining statements, we need to test cases that fit both conditions, statement 1 and statement 2, not to mention the information in the question. It's for this type of circumstance that you want to keep your notes for each case organized and not erased, so that if you have to combine statements, you don't have to redo any work. We can adjust the cases above to obtain the following case. Notice that the GB ratio of A is twice that of B, as is required by the question. Notice also that the total in A is 30 more than in B, as is also required by statement 1. Finally, the ratio of the number of girls to the number of boys in Group A is 6 to 5, as required by statement 2. Now we can try to generate another allowed case. We should always attempt this. However, if we try to get a different case by either adjusting the ratio or by adjusting the total number of people, we introduce a contradiction. This is in fact the only possible case when the statements are combined. Therefore, when the statements are combined, we have sufficient information to know the ratio of one total to the other. It's 110 to 80, or 11 to 8. The correct answer is C.